Chemistry review, balancing equation. So problem is seen at the uh, posted in the screen, and I'll be solving. Balancing is a trial and error. So let's start with the first one. You have a Fe2S3 that is solid. I think um, anyway, S stands for solid, meaning it is usually a crystal. You have HCl, that is a hydrochloric acid. So basically, that is not in a pure form, but it is really dangerous chemical, hydrochloric acid. That's why it is called aqueous, meaning it usually has water if we seen it in a laboratory. Then we have FeCl3, aqueous. Then we have H2S, hydrogen sulfide, or H2S. So don't worry, I'm not also good in naming those compounds. Okay, so this trial and error, you only have to see the first, of course, from left to right, because um, we are fond of reading from left to right. So we just take that road. You have two iron Fe, so you only have to put two on the iron. So again, this is trial and error. It might be wrong, but anyway, we'll just proceed until the chemical equation is balanced. Then next to it, you would see that S3, that is sulfur. You have one sulfur here, so maybe you have to put three sulfur, so that it would be you would have three atoms of sulfur. So you have an S3, so it is also three atoms of sulfur. After that, we go to hydrogen. Hydrogen, you already have six hydrogen in the H2S, so you have to put six hydrogen in the HCl, so that all the hydrogen will be balanced. Since no hydrogen is there is no other hydrogen. And then lastly, you would see that chlorine has now six, meaning there are six chlorine atoms in the left side on the reactant side. So on the product side, we have to count. We have 3Cl here, or three atoms of chlorine multiplied by 2. Again, the numbers before a chemical equation, chemical formula, is we call them coefficient. So when you see a coefficient in a chemical formula, it is carried over to the whole formula. Meaning that 2 is multiplied to Fe, that 2 is multiplied with the chlorine atom. So that must be 6 for the chlorine atom. Likewise, for your 6 um, coefficient for the HCl, you have 6 chlorine. So as you can see, the equation is already balanced. Then the next one, you have KClO3, potassium chloride, I think. It is solid, meaning it is an ionic substance usually. So we'll be dealing with ionic substance first. Um, KCl, another ionic substance, solid, which is a product. This is just, as you can see, that this chemical reaction is, what do you call this? Separation, or probably disintegration into two compounds, and then you have oxygen. Anyway, uh, chemical reaction is another topic. So we are provided with chemical reactions, and we only need to balance this one. Then you have O2, which is oxygen, which is a diatomic gas, or a gas for G. Then by trial and error, we can see that potassium K has one atom on the left and one atom on the right. Then probably we'll proceed to chlorine. Chlorine has um, uh, one, and chlorine also on the right has one. How about for oxygen? You have 3 atoms of oxygen, while this part you have 2. So in order for it to meet, we have to actually, it is more simpler to have the 3 over 2 and then multiply it by 2, all of the equation. Okay? So by that, you multiply O2 by 3 all over 2, then you would have O2 divided by 2, that would be oxygen atom multiplied by 3. So the right side would now have 3 atoms of oxygen because you multiplied 2 times 3 halves. Okay, by that you have 3 halves. But anyway, some authors, anyway, that is correct, but for formality's sake and for, how they call this, for simplification purposes, we usually, some authors avoid uh, coefficients which has a fractional form. So we only multiply all of the equations into 2. So basically it would be 2KClO3. That's a solid, and then it is reacting to 2 products. You have the 2KCl, again multiplied by 2. Everything will be multiplied by 2. Okay, that's for the solid, and then the last one would be multiplied by 2. Of course, that the denominator 2 would be cancelled off. So you would have 3O2. So by that, it should be still balanced. Look, you have 2 potassium atoms. You have 2 potassium atoms. You have two two chlorine atoms. You have 2 chlorine atoms. 2 times chlorine, and then you have 2 times 3. You have 6 oxygen atom. And then through 3 times 2, that would be 6 oxygen. I mean, I'm talking about the atom oxygen. But this O2 is pronounced as oxygen molecule or a diatomic molecule. So just don't be confused with that. Okay? So there are substances that exist naturally, not in elemental form, because if they exist in elemental form, they are usually not stable. So therefore they will just react and then form another compound from that unstable elemental form. So that's why we write things um, in a sensible way. Okay, next one. You have an I4O9. That is again a solid. I expect that this compound is a this is crystals, powder usually. And then you have an I2O5. Again, solid. And then you have an I2, which is a solid. And then you have O2, which is a gas. So basically, again from left to right, um, left to right, I4, you have 4 atoms of iodine. You have 2 atoms of iodine. You have 2 atoms of iodine, so you have 4. How about oxygen? You have 9 atoms of oxygen. How about for this one? You have 5, so basically you still need 4. So since there are 2 here, we just have to put 2. So 2 times 2, that would be 4 atoms of oxygen to complete that 9. So is it balanced? Iodine is 4, oxygen is 9. So it is already balanced. So we proceed. This is the balance equation again. By providing 2 as a coefficient for the oxygen. If ever you have doubled it into 2, that would still be correct. 2, 2, 2, and then you would have 4. That would still be correct, but again, for simplification purposes, we usually resort to the smallest ratio for the balance equation. So some authors might think it is wrong, but theoretically, it is also correct. You can see you have 8 iodine, 4, and then you have 4, you have 8 iodine, and then you have 18 oxygen, 2 times 9. How about here? 2 times 5 is 10. and then you have 8, so you have 18. So again, this is also balanced, but again, what we need really for simplicity's sake, especially when you go up higher, um, what is more simpler is just the simple whole ratio. I think we only need to put a coefficient on the oxygen part. Okay. Uh, did I erase something? So that would be for that problem. And then another one, you have maybe other color. Maybe it would change our perspective. You have a Ba3, N2. Again, that is a solid. And then you have H2O. Um, you have barium. Based on my experience, I think there are just two types of balancing equation. The other one is a oxidation reduction reaction wherein you have to balance the half reactions. So those balancing is somewhat complicated. So you have to start with this one. This is a basic balancing equation. You're provided with the equation, and then your task is to provide the correct coefficient for every chemical species involved. You have Ba3 and 2. So barium, you have 3 barium. Maybe we have to put 3 on that Ba. Then next you have nitrogen. Nitrogen, you have 2 nitrogen here at the left side for the reactant side. And then you have 1 nitrogen here. Maybe we can put 2 on the ammonia, 2NH3. And then let's see the hydrogen. Hydrogen, you have 2 hydrogen here, atoms of hydrogen. Here you have 2, but here you have 6. So how many? We might 3 times 2, sorry. 2 hydrogen times 3. So that would be 6. And 2 hydrogen times 3, that would be 6. So 3 hydrogen atoms for the barium hydroxide, and 3 times 2, I mean 6 hydrogen atoms for the barium hydroxide, and 6 atoms for your NH3 or ammonia. Here we have 2, so probably we have to make it 6. 6 times 2, that would give us 12. So 3 times 2, 6. And then let's see for the oxygen. Oxygen, you have 2 times 3 also. So you have 6 oxygen. How about this guy over here? You don't have an oxygen. So the oxygen is already balanced. We go back, double check. 3 barium, 3 barium, okay. 2 nitrogen, 2 nitrogen, okay. 12 hydrogen, you have 6 and 6, you have 12 hydrogen, and then finally you have 6 oxygen. 3 times 2, again, the numbers outside the parentheses would cover the element or the atom inside the parentheses. So for an OH, your oxygen is doubled and your hydrogen is also doubled. And then the coefficient tells you that all of those are tripled. So 3 times 2, that give us 6. Okay, so thank you guys.